For part A, it says find the minimum value of f, and it gives us a closed interval. This is the graph of f prime, so the first thing we're going to do is check where f prime equals 0, and that occurs at 0, 4, and 6. Next, to have a minimum value for f, that would be where f prime changes from negative to positive. So I kind of label these positive to negative, this stays negative, negative, and then right here at 6, f prime changes from negative to positive, indicating that f has a relative minimum at x equals 6. So this is the sentence you want to use. Since f prime changes from negative to positive at x equals 6, f has a relative minimum at x equals 6. So now we're going to call this one of the candidates for the absolute minimum of f on the closed interval. What we want to do is we want to check the candidate here, and we want to check the endpoints. When we check, we plug them into the original function f. So for the first endpoint, x equals -5, we're going to evaluate f at -5. Okay, the really important thing to note at this point, to find f of -5, we know very little information about the actual function f. We have this for f prime, and then you want to note the initial condition. So this is going to be the key right here, f of 6 equals -1. So to find f of -5, what we're going to do is we're going to use the initial condition that we have. So we start with what we have, and then we add to that what we have to what we want. So this is going to be the setup that we're going to use. So f of -5 equals the initial condition, and we know the value of f at 6. So you set up an integral from what you have to what you want of f prime. So I plugged in f of 6, and then flipped this and brought out a negative. At this point we need to evaluate this, and this is the area under the curve of f prime from -5 to 6. So from -5 all the way to 6, you have this triangle which will be positive, you have this semicircle which we'll label as negative, and this triangle is negative. So this is 1/2 base of the triangle times the height of the triangle. This is the semicircle, negative, and then 1/2 pi r squared. And then this is the little triangle that's below the x-axis, that's why it's negative, 1/2 its base, its height. I simplified this down and you get -13/2 plus 2 pi. On a calculator, that's approximately -0.22. Next, we're going to plug in the relative minimum of 6, and we're given that. Last, we're going to plug in the other endpoint. To find f of 10, we're going to do the exact same thing we did for f of -5. So f of 10 equals f of 6, which is what we have, and then we add to that the integral from what we have to what we want of f prime of x. So I plugged in -1 for f of 6, and then this is already in the right order, so now we're just going to do the area under the curve from 6 to 10 of f prime. So from 6 to 10, it's just the area of this triangle, and you get 3. Always on these types of problems, make sure you go back to the original and reread the problem to make sure you answer it correctly. It says find the minimum value of f. So it wants the actual minimum value, it doesn't want where it occurs. So between -0.22, -1, and 3, -1 is the lowest value. So I wrote it out, therefore the minimum value of f on the closed interval from -5 to 10 is -1. For part B, we need the derivative of g, so we're going to chain rule. Take the derivative of the outside, leave the inside the same, and now we're going to take the derivative of the inside. The derivative of 3 is 0, and the derivative of this part of the problem is negative f double prime. I plugged in 6 for x, so f prime of 6 is 0, and then f double prime is, since this is f prime, f double prime will be the slope of this tangent line. So right here, the slope of the tangent line of f prime at 6 is going to be +2. So f prime of 6 was 0, and f double prime of 6, which is the slope of the tangent line of f prime, is +2. So you get -2 cosine of 3. We're starting at 5, and we need 2 steps of equal size to get to 3. So that means we're going to have 4 in between, and our change in x is going to be -1. We're going to use 5 and 6. We're going to plug them into here to get our dy dx. We're going to get f prime of 5 from the graph, so f prime of 5 is -2, and then we're going to add y and change in y. Okay, so we're going to do the process again. F prime of 4 is 0, so we end up getting 22 divided by 5 times 4, so h of 3 is approximately equal to 33 over 10, or 3.3. When you have the absolute value of v, and it tells you that v equals f prime, we're going to take this f prime graph, and any parts where the graph is below the x-axis or negative, we're going to reflect them up to make them positive. Oh, that was messy. But anyways, this half of the circle is now up above the x-axis, and this triangle is above the x-axis. So I just rewrote this so we can visually see that the integral from 0 to 10, absolute value of f prime of t dt, is representing the area under the curve from 0 to 10 of this semicircle, this triangle, and then this triangle all the way to the right. And here's the setup: 1/2 pi r squared, r is 2, 1/2 base height, and 1/2 base and height. So you end up getting 2 pi plus 6. With units, we want to explain the meaning of the value that we just found in context to the problem. So I just made a note that when you have the absolute value of the function, to find distance traveled, not displacement. So I wrote this out: the integral from 0 to 10, the absolute value of v of t equals 2 pi plus 6, represents the total distance traveled by the particle in meters from t equals 0 to t equals 10 seconds. Here's the third degree Taylor polynomial for k about 6. So now we just need to find k of 6, k prime of 6, k double prime of 6, and k to the third derivative of 6. The derivative of k for this part is going to be 2, and then right here we're going to apply the fundamental theorem of calculus. We're going to take the x and plug it in for t. So there's your expression for k prime of x. And then the derivative of negative f of x is going to be negative f prime, and then also this will be negative f double prime of x. When you plug in 6, you get 12 right here, and then the integral from 6 to 6 would be 0 area, so you just get 12. When you find k prime of 6, we plug the 6 right here. F of 6 is given in the original problem as negative 1, so this ends up being 3. K double prime of 6 is going to be negative f prime of 6. F prime of 6 from the graph is 0, so you just get 0. And then the third derivative of k at 6 is going to be f double prime of 6, and the slope of the tangent line of f prime at 6 was positive 2, so this becomes negative 2. I plugged everything in, so now I'm going to simplify. This term completely goes away. Over here, be careful, this is 3 times 2 times 1, so the 2's cancel. And there's our final answer. Just a heads up, you can leave these factorials in your final answer on the actual AP exam. You don't have to simplify to get down to here.